No worries. You will. I just apparently when I saved it, somehow it has a glitch. It just saved the first page. So you can go in, it's at the very top, solutions. Okay, again, I'm so sorry, Derek. Which one you had in mind?
Number 3.
Number 3. Oh, the Riemann sum.
Yes.
Okay, so the f of x was 2x cubed plus 3, and the interval is 0 to 4. Okay, very good. So let's take a look. So remember we have 3 preps. Without these 3 preps, we cannot start the limit of the Riemann sum. The first prep is delta x, which is 4 minus 0 over n. The next prep is xi, which is 0 plus I delta x. But since it's 0, this is 4I over n. And now I have to determine f of xi, f of 4I over n, which is 2 4I over n to the third and plus 3. So then this will be 4 to the third is 64. 64 times 2 is 128. I to the third over n to the third plus 3. So now we can determine the area as the limit as n approaches infinity from delta x, which can be taken out, and this is the sum of this plus this. Sum from 128 I cubed over n cubed and plus 3. Of course, from I equals 1 through n. So now it's the sum of this plus the sum of this. So I'm going to skip one step if you allow me to, and just put this constant in front already, 128 over n cubed, the sum of I cubed. And now the sum of 3 is basically 3 times the sum of 1. From I equals 1 through n, from I equals 1 through n. Okay, so now this will be replaced by n plus 1 divided by 2, everything squared, and this will be replaced by n. I saw something interesting and fine. One of your colleagues already applied the limit to this and a limit to this, and she said, okay, I'm going to just call this 3. That's fine too. It's perfect. I like that. Okay, so my next step is the limit as n approaches infinity 4 over n. And then we have 128 over n cubed times n squared times n squared plus 2n plus 1. Don't forget this becomes now 4 plus 3n. I will simplify. And I get the limit as n approaches infinity 4 over n. The least common denominator is n. I don't need to do anything here, just distribute 64. 64n squared plus 128n plus 64, and plus this needs to be multiplied by n. 3n squared. So now limit as n approaches infinity, 4 outside, n squared in the denominator, 64 plus 3, 67, n squared plus 128n plus 64. And what else? We can continue with L'Hopital's rule. Or we can just simply say that when the degree is the same, top and bottom, and the limit is determined when n approaches infinity, it's just the leading coefficient over the leading coefficient. 4 times 68, 7 divided by 1. Or you continue with L'Hopital's rule, and you still get the same thing.
I have one issue.
Yes.
Shouldn't that, so in the first line, right? Shouldn't that 128 have become, should that have become 128 divided by 4?
So,
32?
so I simplified 4 with 128.
Yeah, but you wrote 64, because 128 divided by 4 is not 64.
It isn't. It's 32. Thank you.
Yeah, so, because the answer should be, what, 140, correct, on the test, I believe?
I believe so too now. I was looking at it. Okay, sorry. 128 divided by 4 is still 32. How dare you no, I'm so sorry. Yes, it is 32.
So that would make it 35 n squared.
Plus, yes, this one is for 35 now. Yes. Thank you. I was just looking at it, and what did I do? Yes, 128 divided by 4 is still 32. I promise you.
Okay.
I wasn't
Alright,
trying.
thank
No, I wasn't trying to change math at all. It is 32, of course. So from here, take L'Hopital's rule, or what do you want me to do? You want me to continue with L'Hopital's rule? I was just waiting for you to tell me.
No, it's okay. I got it from here.
Okay.
All right, thank you.
Thank you. Sorry. Thank you for keeping an eye on my numbers. Good. Anything else? And no, I wasn't checking. Yes, which one?
This problem, why do we multiply Pm by M?
Because you cannot add fractions that don't have the same denominator. This fraction has denominator n, and this fraction has denominator 1. So it's like 1/2 plus 3. So 3 is 3 over 1, so you need to multiply by this. So we get 1 plus 6 over 2, which is 7 over 2. Is that okay?
Yeah, thank you.
Thank you. I wasn't trying to see whether you were asleep or if anyone was following. I was just not even thinking. No excuse.
I have another question.
Yes, I'm ready. Yes.
Could we go over one of the inequalities, like on the last test?
Any.
Number 6 on the test number 4.
Yeah, let me look. I don't remember exactly what it was. Number 3, 4, 5, 6. Yes. So the integral from 0 to pi over 2 x sine x dx, let's say they ask us to show that this is correct. Okay, perfect. If you remember, we always start with x. So that's our starting point. And realize that function sine between 0 and pi over 2, 0 and pi over 2 is an increasing function. So sine at 0 is 0. Then sine x and sine at pi over 2 is 1. So I have this piece already, but I also need the x. So I'm going to multiply by x all 3 sides. I really don't need this side though. There is no need. It's going to be 0. So I have x sine x is less than or equal to x. So I found two functions, one that is below the other. And if that's the case, then the integral from the first one, from 0 to pi over 2 dx, will be less than or equal to the integral from 0 to pi over 2 from x dx. One remark, many times I saw it on your tests, you write the integral without dx, or dy, or dz, or dt. You cannot do that. Please make sure that you always write the integral with dx. There is no integral without dx or dy, dt, whatever the variable is. So now when I calculate this, I have x squared over 2 from 0 to pi over 2. And I don't plug in 0 because it's 0. When I plug in pi over 2, I get pi squared over 4 times 2. So this is the pi squared over 8. And that's all you needed to do.
So we just applied the. So how come we didn't have to apply it to the x? Why do we only have to apply it to the sine x?
Say it again.
So
We were asked to show that this integral is a number less than or equal to pi squared over 8. We were not asked to calculate this. We were asked to just show that this number is less than pi squared over 8. And we use the property of the definite integral that says if a function is below another function, the area below this function is less than or equal to the area below this function.
so because the x function was larger.
Yes.
Okay, that makes more sense. All right, thank you.
Yes. We show that this function is below this function. So the property says that if on a particular interval I show this, then the integral from a to b from f of x dx must be less than or equal to the integral from a to b from g of x dx. It's one of the properties of the definite integral. So here that's what we showed. We showed that x sine x is less than x. So in other words, I found this function, which is f, and I found this function, which is g. Therefore,
So the f of x was x sine of x, and then g of x was just x, right?
correct. So once I show that these two functions, one is smaller than the other, on a particular interval between 0 and pi over 2, then the integrals follow.
Okay, all right, thank you.
Better?
Yes.
Perfect. I want to thank everyone for uploading within literally 6-7 minutes. I'm very pleased to see that. Thank you. Because you understand normally the test would be in class and you will turn it in the moment you exit the room. So that's why I need your work as soon as possible. So thank you for doing that. Next question, is there anything else you would like to work on? Anything else? I'm ready. If you review all tests with solutions